Hey guys and gals, how you doing? How are you doing today, this fine day? Appreciate you being here. Thank you for hitting that play button. Turn that up. You know I love that. This is great having you here. Learning and growing. I love it. I love it. Let's quickly check the stream and then we're gonna get right to work, guys and gals. Let's get right to work. Hopefully you're ready. We're good. Sounds like we're golden. Golden like the Golden Girls. I don't know why that's funny. I like saying it. It's funny. It's kind of funny. So, awesome sauce. All right, so last stream we kind of reflected a little bit on just kind of review and, just kind of correcting any, minor mistakes that were made. And then making sure that we're all good and we got the correct information. Because that's what matters. All right, we're working on temperature this stream, guys and gals. Temperature. Let's go. So we've got all this done already. Here we go. Now, I believe I went over description of temperature. We'll just kind of go over, I don't know, do we go over something? I don't know. What is temperature? We'll just do a basic kind of definition here, okay, guys? What is the definition of temperature? Temperature is defined as a measure of how hot or cold something is, and it specifically relates to the average kinetic energy. Kinetic energy means energy in motion, guys. To the average kinetic energy of the particles within an object. Okay, atoms and molecules kind of move together and create friction and bang and bounce against each other. In simpler terms, it reflects the degree of internal energy an object possesses due to the movement of its atoms or molecules. Okay? Elaboration, average kinetic energy. Temperature is not about the total energy of all particles, but rather the average energy of their motion. The faster the particles move, the higher the temperature. Right? Indicating more energy is stored as heat. Direction of heat flow. Temperature also indicates the direction in which heat energy will spontaneously flow from a hotter object, higher temperature, to a colder object, lower temperature. So, obviously, what was said there is basically if you have a hot object touching a colder object, that heat will actually transfer to the colder object, essentially. Okay? Thermodynamics 101 stuff. Okay, measurements. Temperature is measured using various scales like Fahrenheit, Celsius, and Kelvin. Kelvin is used. The numbers are actually quite different, but for the most part, the most common one is Fahrenheit, Celsius. Now, if I go Celsius to Kelvin, for example, I'll even do maybe one for Fahrenheit. So we're going to clean this up. I meant to clean it up a little bit more earlier. That's okay. We're just going to go like this quickly. I might actually clean up this whole thing right here, guys. And then we're going to continue. Just increasing the size. Whoops, that's the wrong one. Just gotta click my eraser. Let me just zoom this up here. We don't need this anymore, so we're just gonna get rid of it. We need the space for working. Bear with me, guys. It's kind of like watching the instructor clean the chalkboard, and you're here because they're probably even terrible at that too. Let's go. That deserves a yays. Deserves a yays. And I'm gonna get rid of this line as well. Okay, let's no, not opacity. Let's change this back to 32, and there we go. Okay, so we don't really need to know this, but 0 degrees Celsius is equal to let me just go here a little bit. 273. You don't really need to know this, but whoops. 1.5. And I believe K is what they use for kelvins. Okay, let's go F to Kelvin. Fahrenheit. So, yeah, it's basically kind of the same thing, right? 0 degrees Celsius is exactly the same thing as 32 degrees Fahrenheit equals, well, it's the same value. Okay? And I'm just going to write Kelvin. It's kind of like Kevin, but with an L. So that's quite a difference, right? We don't normally use that. Key concept. The concept of temperature is crucial in understanding heat transfer and the behavior of matter in different states. Okay? There, that's done. I wanted to quickly kind of show you guys and gals the calculator that I'm using. Not that it's important or anything. To be honest, it seems like they still sell it. You don't really need, like if you're in high school, you don't really need a super fancy calculator. You can just kind of get them basic, cheapy, scientific ones at Walmart or whatever. They're usually, I don't know, anywhere between $5 and $20, somewhere in there. The one I'm using is typically over 100. Let's see. Let me just go to my pictures. and I'll just share the thumbnail. Okay, that's essentially it there. Okay, close that. And we have also this, which I'll, I guess, share. I think, yeah, it's okay. I think we're okay. So I could actually zoom and kind of show you. Excuse me. Excuse me, guys. I don't know. All of a sudden, I just got an itchy throat. It's more of an engineering calculator / scientific, and there's a case for it as well. Okay, we're gonna get rid of that. So it's just a suggestion if you want it or not. I mean, it pretty much does. You could store a lot more. Obviously, you could do graphing on it as well. There may be some how-to websites or such on how to use the calculator. Usually, like this one particular, because you know, there's a little bit of reading you're gonna have to do on how to properly use it. It's a basic standard calculator everybody knows how to use, but if you've never used one like this style before, I recommend you read the book and stuff and such. Understand a lot of the buttons you'll recognize, but you can do graphing and such on there. I know my Sharp, which I kind of miss. Yeah. I don't have it anymore. I'm not gonna share that story. It's not. I'm not a. Not the. Yeah. Let's just say it ended up in a pawn shop. Okay, it wasn't me. Wasn't happy about that. So that's kind of the quick gist of that story. I miss my Sharp calculator. But that one was cool because I could actually take like big formulas when I was in college and like just write up a little program, and all I had to do was just enter in values. It was great. Some formulas can get pretty large, right? Okay, so with that said, let's just carry on. Just wanted to kind of share that quickly. We're gonna clean this up. Okay, and that's it for that. I need some coffee just to clear up my throat here. All right, let's get to work, guys. Okay, so we're gonna be, so right here is, because we, here, let me just explain why we have to do this. If you can see, we have the temperature conversion formulas. This one's for if you want to know the answer in Fahrenheit, and this one's if you want to know the answer in Celsius, right? These are the knowns, right? The givens. If you know the Celsius, but you want to convert to Fahrenheit, that's this formula. If you know the Fahrenheit, but you want to convert to Celsius, that's this one. So obviously we're going to have to kind of practice a little bit of basic mathematics. And let's do that. So that's kind of what these examples are. All right, guys? Excuse me. So hopefully, I don't know if you've heard of it or not, but there's this term called bed mass and ped mass. Basically, excuse me, these are your brackets, right? Okay, that's what they're basically referring to. Okay, I know I'm kind of like, there's no need to explain this, but there's another another term for it as well. Oh, goodness gracious. I'm gonna erase this, but they're also called trying to do it fast here. Parentheses. Okay? I always mess up parameters and parentheses all the time. Parentheses, parameters, parentheses. Potatoes, tomatoes, tomatoes. Doesn't really matter because they all cook the same and do the same thing. All right. Okay, so if you see those, that's what these are. Okay, ped mass, bed mass, it's all the same, right? It's called ped mass because of parentheses, right? So the steps are, you have to do everything in brackets first, okay? So just ignore all this. This is how I teach math. If you have a plus sign, think of it as like a fence, okay? This is one neighbor, and this is the other neighbor, okay? We really can't get the neighbors to hang out until we get rid of the fence. I don't know if they want to hang out or not, but this is kind of how I do it, right? You have to look at it as the plus minus is kind of like a separator. But if you look here, it's the very last thing you do, okay? So you could really ignore the plus sign here right to the end. Okay, guys? So the rules are brackets, anything in brackets is done first. If you have exponents, right, sometimes you might have a squared outside the brackets or a cubed. You would still do everything inside the brackets and then you do the exponents, right? So if this was squared, you would do everything inside till you get a whole number or a fraction or whatever it is. Could be a decimal too, I guess. And then you do the exponent. And then if there's any division, subtraction, again, anything inside the brackets, even if it has division, you would still, technically speaking, still do it, right? Because it's inside the brackets. Okay, guys? So you really need to get rid of the brackets and anything. You want a singular value. And once you have a singular value, whether it's a whole number or an integer, I guess, positive or negative, or whether it's a fraction or a decimal value, you just want a singular value, right? And then you can add it to the plus 8. Okay, so these are the steps. Okay, hold up. That was actually the first commercial, so I have no reason to complain. Cool, back to music. Turn it back up. I have to make sure it's not too loud. Okay, 3/4 times 16 in brackets. Let's just do some practicing. 3/4 times 16. If I recall, it's plus 8. I'm going to use up all the space. Just like whatever, right? Okay. Again, I guess I could erase this, but I'm just going to go bed mass here. Just so that you guys can see it visually. Okay. Brackets, exponents, division, multiplication. Either, when you're dividing, multiplying, it doesn't really matter the order. So you could kind of swap these. Like, think of it, these as all parts. 1, 2, 3, essentially. Right? So, brackets or parentheses, it's all the same. Okay, let's double check. Make sure we have everything correct. 3/4 times 16 plus 8. Okay, guys, take note of something here. Okay, if you have here, let's look at this value 16. Check this out. This value 16, we don't really write it, but this value 16, this whole number, is actually over 1. Okay, anything, it doesn't matter, right? It's still going to give you that result. You could divide it by 1, you're still going to get 16, right? So if you want to put your fractions into numerator over denominator, you can. Okay, so check this out. That's why I'm showing you guys this. So, because a lot of people might get confused. Oh my goodness, what do I do? Where do I start? Right? Like I said, I'll just write it over here. I guess I'll erase it later, just so you can see, right? That 16 is over 1. So you could realistically go 3 times 16 all over 4. In brackets. Should have just left it because it actually was fine. And then plus 8. I'm just kind of separating. I'm kind of moving the 8 over a little bit more. So it's, again, just pretend this is a fence. Okay? It's the last thing you do. Alright, so always get the stuff in brackets first. We could actually, to save some time, we could reduce this. Check this out. We know that 4 goes, remember how I was talking about factoring? I'm kind of, skipping a step. It doesn't really matter. You still, for the most part, guys, you usually have to reduce a fraction anyways. Okay? So you could do what's called factoring. You can pull as much meat out of the bone as possible. So you know that 4 goes into 16, right? 4 times 4 is 16. Right? If we actually factor 4 out of these two numbers, just ignore the 3. We're just going to factor from here. So I'm going to go like this. I'm going to go like this. This becomes 1. This becomes 4. I just saved some work. You see what I did there? So now all I have is 3 times 4. This is simplifying it, right? Over 1 plus 8. So basically, I'm left with 12 plus 8. Right? I could do the long work. I just kind of save some extra work. And again, you can see, the answer quickly now. A lot quicker. Isn't it easier than trying to multiply 16 times 3 in your head? I guess I could try. Well, I know 16 twice is 32. And then I'd have to add another 16 to that. 6 and 2 is 8 plus another 1. It sounds like it's 48. Now if I check my calculator, see if I could actually math in my head. 16 times 3, right? 48, let's go. So then I would have had to go 48 divided by 4, right? I would have had 48 over 4 if I did the numerator part, right? That's what I would have had. So wasn't that quicker than, you still have to reduce. I still have to divide it by 4 or factor. I would have to factor 4 out of both the top and the bottom. Factoring is like this. You're just kind of pulling out as much meat off the bone as possible. So this would become 1 and this would become 12, right? 12 times 4 is 48. 4 times 1 is 4. I know it's a little bit messy, but essentially this is a lot cleaner, and I could quickly go 3 times 4, and you'll probably get your exam done a lot quicker. Again, guys, when you're working on an exam, figure out what's the total number of questions you have. Now, do you have 60 minutes or do you have 120 minutes, 1 or 2 hours? And then you have to divide the time by how many questions. So let's say you had 30 questions and you only have an hour. That means you have 2 minutes per question. Okay? Some questions you might be faster than the other, but you have to average it, right? I give you that advice because when I was doing my chemistry exam, I studied pretty, intensely on it, and I thought I was just going to ace it. I felt so confident. But it was the multiple choice that killed me because I spent too much time overanalyzing, overthinking. And I wasted so much time. And then by the time I got to the fun stuff of chemistry, like writing down all the formulas, I had to smash out, I couldn't even get it all done. I only had 5 minutes or something. I can't remember how much time I had left, but I don't think I failed it, but I would have did a lot better. Again, that's my advice. Don't waste a lot of time on multiple choice. If you don't know the answer, just put a little tick or something and just skip to the next question. Go back to the end of it. You're better off having a 0 on a multiple choice than getting to the end of your exam that's maybe worth 20% of your mark and not getting that completed, because that's worse, right? You understand? Those are kind of my school tips for you. Okay, so there you guys go. All right? And obviously the answer is 20. I don't have the answers in front of me, but it sounds like that would be the correct answer. Okay, I'm just going to undo all this. Hopefully I don't lose any of that stuff up top. I think this is a lot better. Whoops. I want to keep that, actually. I don't want to lose that. I just make my eraser bigger so that I know that I'm going to get rid of all this. Using the eraser because I want to keep the bed mass stuff there for you guys. Okay, and 32. There we go. Okay. All right, let's continue. Okay, again, these problems are just so you can practice. They're practice because we have to eventually, we're going to be doing this sort of thing anyways, right? So it's for practice. Okay, let's do this other one. 5/3. Now, if you look at it, this one actually looks like the Fahrenheit one, and the other one looks like the Celsius one because it has the minus in there, right? Okay, 5/3. Come on. 5/3, 12, subtract 3. All in brackets. Okay, same thing, guys, right? Bed mass rules. It's the same thing. Imagine this is the neighbor. Okay, that's the fence. You have this side and you have this side. Okay? So, brackets, always do the brackets. So you might as well just rewrite this. And then essentially brackets infers multiplication. 12 take away 3 is 9. Okay, so it's the same thing, guys, right? The 9 is 9 over 1. Okay, So all you really need to do is go 9 times 5, right? I could write it all out. Doesn't really matter. So we have 5 times 9 all over 3. Okay, I could do the same thing here. So I know 3 and 9, right? We'll just ignore the 5. It's multiplication and division. You could do this stuff. You could factor before you even multiply stuff. So, because you're going to end up having to do it at the end anyways. You might as well just save yourself some work now. Because there's smaller numbers, right? So let's 3 times 3 is 9, right? We know this. Okay? So I'm just going to go like this. So if I pull 3 out of that, that leaves 1. If I pull 3 out of this, that leaves 3. So I'm left with 5 times 3 over 1, right? Because that's 1 now, which is 15. You could do the long work if you want. 9 times 5 is 45. 45 divided by 3, still 15. Okay, guys? Isn't that a lot easier visually to see? It's a little bit messy kind of doing that. You could do an extra step if you want, right? So that you don't get confused. You could go 5 times 3 all over 1. Right? That's kind of what you're left with. I could go equal sign here just so that it looks like I'm continuing my work. Right? Again, this is still all going to be over 1. This is still all numerator. Okay, guys? That makes sense? I hope so. Right? It's no different. No different. All right. I think we need to drop in some yays. Yeah, we're already, time flies when you're having fun, man. Whew. I get a sneeze. It's coming. A sneeze coming out of nowhere here. Or I don't have to. I don't know. Felt like it for a sec. Yeah, I do. Okay, guys. Excuse me. Thank you for your understanding. Let's undo this. We're going to do one more quickly. And then we're going to do some other practice ones. Okay, ratio proportion. You could ignore that. We're not really doing that right now, but I'm just kind of leaving this stuff up here for in case we do need it. Okay, ignore all that. Let's continue. All right, what's the next problem here? So this one's going to be similar to the Fahrenheit one. Okay, so might as well get used to it, right? So we got A and B done. We're doing this one now. All in brackets, 2/5. Multiplied by 15. I'll write it exactly the way it is. This is all in brackets. Plus 7. Okay, remember guys, imagine the plus sign is a fence, right? Separate it. Left side, this is neighbor 1, this is neighbor 2. Okay? First you have to talk to neighbor 1 before you can talk to neighbor 2. Whoops. All right. Same thing, guys. 15 is a numerator. Okay, so we could actually write it all into one big fraction. 2 times 15. It's going to be all over 5. I know you're going to be safe doing this. We're not adding or subtracting here, guys, right? When you're adding and subtracting with fractions, you have to find a common denominator. So I've grinded a lot of math problems. You just have to trust and believe, okay? You're going to be safe and you're going to be fine. This is multiplication and division we're doing. Okay? So you're safe putting all of that over 5. Okay? Again, it's not adding and subtracting into brackets. If we were adding and subtracting inside here, we would have to find a common denominator. But that's not the case. Okay? So same thing here, guys. Instead of going, we can still do it. We know that 2 times 15 is 30. What times 5 gives us 30? Well, that's 6, right? I already kind of know the answer. But let's say we had really large numbers. Let's reduce. So we're going to go like this. I'm just going to write it again so that you guys could see without it being too messy. Okay? We know 5 goes into both, right? What times 5 gives us 5? Well, that's 1. What times 5 gives us 15? Well, that's 3. I'll write that a little bit better. Okay? All right, so now we're left with 2 times 3 all over 1. I didn't need to write over 1, but I just wanted you to see it, right? So we have 2 times 3 is 6. Plus, don't forget so this is neighbor on the left side. Don't forget the neighbor on the right side. Now it's addition, subtraction. Okay, which is equal to 13. Okay, guys? Boom shakalaka. That was kind of quick. Let's do one more. These are for practice, guys, right? That's the reason why they have them there. Just so you can get used to doing this kind of stuff prior to using the formulas. Okay, number 2. 14 times 5 over 7. It doesn't really matter the order. Don't let it confuse you. It doesn't really matter. Again, when you're multiplying stuff, it doesn't matter if the 14 is on the left side or if the 14 is on the right side. It does not matter. Okay, 5 over 7. Okay, and that's all in brackets. Plus 6. 14 times 5 over 7 plus 6. Okay, there. Same thing, guys. I'm just gonna, I've explained it, and I know a lot of you already understand it. We're just gonna go like this. Let's simplify it. Make it easier visually to see. All over 7. Again, it's all multiplication. You're gonna be fine. Just gotta trust. Okay, so we can factor right here. Okay, same thing. So I'm gonna factor, and let's just show you what we're left with. So What times 7 gives us 7? Well, that's 1, right? So I'm going to factor 7 out. What times 7 gives us 14? Well, that's 2. We didn't touch the 5. Don't forget the 5. We haven't done anything. It was just hanging out. The 5 is just hanging out there. We're only focused on this and this. I just factored ahead of time to save some extra work on the back end. Trust me, I've grinded enough problems to know quicker ways. So we're left with 2 times 5. Isn't that simpler? Look at that. We're just left with 10 plus 6, which equals 16. All right, isn't that awesome, guys? All right. Okay, cool. So what I'm going to leave you guys with, okay, let's go here. I'm going to zoom this up. Okay, so we've done this one, we've done this one, we've done this one, and we've done this one. Okay, I want you guys to do this one and this one before you go to the next video. Okay, I want you to practice it and see if you can get the answers. Okay, now don't worry if you make a mistake. Okay, don't be hard on yourself. Okay, for me, the best way to get at algebra is to grind. I'm just going to go with a random number. 10,000 algebra problems. Okay, the more you do, the better you're going to get. Okay, you won't have to do 10,000. I'm being a little ridiculous. But that's how I got awesome at algebra, because every problem is a little bit different and it has little different steps. The more you grind, the better you're going to get. Okay? All right, so in case maybe I'm going to zoom it up so you can actually see. Okay? 2/3 in brackets, 10 plus 2. 3/4, and in brackets, 23, take away 3. And I'll see you guys in the next video. And good luck. I know you're going to do it. Let's go. All right, thank you for watching, parents. Whiskey Tango Sharp. Coding / mathematics, I guess. Here to support you guys. I understand fully your decision why you're homeschooling, and I support you in that endeavor. Yeah, I'm just here to give you some additional support for your child. Hopefully it's helping you out. Same thing with students. If you're just here to, get better practice, you're 100% welcome as well. That is it. I'll see you guys in the next video. Name's Johnny, and yeah, whoever you are, wherever you are, take care, and we'll see you guys in the next video. Peace out.